What is up, everybody? It's Mr. Holtz, and today we are going to be talking about emission spectra. So earlier this week, we talked about what happens to atoms when they absorb and emit electromagnetic radiation, and how we can get different colors of light from certain kinds of atoms depending on how we energize the electrons, and what happens with those electrons when energy is released as they drop back down from an energized state to the ground state. Okay, now we're in the back chem storage room to do this today because this is the only room in the science department that doesn't have any windows, and it's really important to make sure we don't get any other visible light coming in from the outside to interfere with what we're going to be looking at as we take this blue light and try and separate it into the different wavelengths that are actually mixing together to give us this awesome blue. So right now what I have is a sample of mercury in this tube, and I have it in this super high voltage lamp. Okay, so this is kind of like the neon lights that you guys see in restaurants or liquor stores or gas stations or whatever. But we're going to be taking this light and separating all of the different wavelengths that are in this to see what are the different levels or amounts of energy that are being released when the electrons in this actual atom of mercury are being energized and then dropping back down to the ground state. All right, so let's take a look. So our setup for today is right here. We've got a spectrum tube power supply. Okay, so it's basically just where the electricity is coming from to light the gas. And then I'm going to be replacing different tubes. Here you can see the first one says hydrogen on it. So let's take a look at this hydrogen light. It's kind of hard to flip the switch. There we go. Okay, so here's some hydrogen gas. And just like those neon tubes that you guys see in like open signs or any other kind of restaurant or business that has signs that light up with different gas colors. So here's hydrogen, but what we're going to do today is we're going to take a look at the emission spectra of this hydrogen lamp. Okay, so we're going to be using this little tool right here, which basically has a tiny little slit right here for light to go through. Okay, so the light that's being released right now, this kind of purplish violet pink color, is going to go through this slit right here. And what we're going to be doing is we're going to be looking through this end, which, as you guys can see, is reflecting all the colors of the rainbow right now. Okay, so this little piece of plastic here is going to act as our prism that separates all of these colors of light. So what we're going to find is that the light that's being released from this tube right here is not just pink light. Okay, so the light that's actually being released is a combination of all of the different wavelengths of light that can be released when the electron in hydrogen is going up and down in those energy levels. Okay, so depending on how much energy it gets, it could go up a level, maybe it could go up 2 levels, etc. But when that electron drops back down into the ground state and energy is released, depending on whether it drops from 2 to 1 or 3 to 2 and then 2 to 1 or 3 to 1 or something like that, a different combination of electrons dropping from certain energy levels back to the ground state will give us different wavelengths of energies of light depending on the energy difference between where the electron started in the ground state and which energy level it was energized to. Okay, so let's take a look at what happens when we turn off the ceiling lights and we look at this light through the prism. All right, so right off to the left here, you guys might be able to see those different colors. I know this is kind of hard to film on my phone, but as we cross over, you guys will see the brighter pink light on the right side. So that's actually all of the light that's coming through from the spectrum tube. So right here, off on the left side, you guys can see how those colors are kind of diffracting into a range of colors. But there are a couple lines over in the bluish violet and in the red where those lines are really thick compared to the rest of the colors that we see. So that's actually the main points at which electrons are releasing those wavelengths of energy when they come down in energy levels, okay? So when they're returning to the ground state, that red line is equivalent to the wavelength that is released for some changing of electrons from a higher energy level back down to the ground state. And then that light over on the blue is also representative, but that's going to be a bigger drop, right? Because blue has a shorter wavelength, higher frequency, so it has more energy associated with that color. So more energy is being released at that point from the electrons that are releasing energy as they drop back down to the ground state. Okay. Okay, so we just looked at hydrogen. Now we're going to take a look at helium. So this right here is a sample of some helium gas. Okay, as we can see, the color is way different than with hydrogen, right? Hydrogen's overall color was a nice bright pinkish light violet. Okay, now we're getting kind of a bright yellow with a little bit of an orange tint to it. So let's take a look at what the colors look like when we separate all of them based on their wavelength, right? Because this is just a combination of all of the different colors that can be released when the electrons in helium drop back down to the ground state. So let's take a look at what happens when we separate all of these different bands or wavelengths of light. Okay, so now we're looking at a helium atom, and as you guys might be able to see off on the left-hand side, as the wavelengths of light are being distributed from the overall light that's coming out of this lamp, there are clearly more obvious lines than there were with the hydrogen atom. Now this is due to the fact that helium has an extra electron, so the combinations of energy that can be released when the electrons in the atom drop back down to the ground state is a little bit more complicated than it can be in hydrogen, since there's only one electron, right? So anytime that electron comes back down to the ground state, it's only releasing one wavelength of energy at a time. Okay, but now there's a more complicated mixture because there's multiple electrons that we have to take into account in terms of the structure of this atom and where electrons are going when we energize the atom itself.